Imagine a tremendous gathering played by a perpetual number of stars, planets, and moons, all performing together superbly. However, there is one specific fragment of this celestial ensemble that has intrigued space specialists for a significant time: exoplanets. Exoplanets are ordinary planets that exist outside our solar system, hidden somewhere deep in the Milky Way. You might be surprised to find that among the countless galactic objects, there are exoplanets so remarkably similar to Earth, so tantalizingly alike yet puzzling, that they might be considered our planet's divine twin. One such fascinating world is Proxima b, located just 4.2 light-years away. The James Webb Space Telescope is revolutionizing our quest to comprehend these celestial mysteries. Imagine a moment when your mind ventures across the vast expanses of reality, the Milky Way, a galaxy home to over a quadrillion exoplanets. That's a number with 15 zeros. To put it into perspective, if each exoplanet were the size of a grain of sand, we wouldn't simply fill the Grand Canyon. We have enough to create another landmark, Grand Canyon 2.0, stretching for an incredible distance. Even more astonishingly, around 20% of these glorious celestial bodies are designated Earth-like in terms of geology and atmospheric structure. This means there's a 1 in 5 chance of finding a twin of our planet, and the story doesn't end there. Accompanying these planets could be another quadrillion moons, rocky satellites like our moon, engaged in gravitational dances with their parent planets. If you've ever pondered finding another body in space that harbors life, or could do so, the universe offers an overwhelming flood of possibilities. Now, as we unravel the unimaginable scale of the cosmos, it's time to introduce the master craftsman poised to paint its complex nuances, the James Webb Space Telescope. This celestial Sherlock Holmes, equipped with amplified adjustable central focuses, surpasses even the most advanced optical instruments. Its 6.5-meter primary mirrors are 2.7 times larger than those of Hubble. Imagine the incredible detail it can discern, capturing even the faintest glimmers of stars billions of light-years away and analyzing the subtle details of orbiting planets. What sets the James Webb Telescope apart isn't just its seeing power, but also its cutting-edge technology. Advanced sensors and spectrographs enable it to do much more than observe. They analyze and decode the unique light signatures emitted or reflected by celestial objects. These tools decipher atmospheric conditions, composition, density, and even mass. Acting as a space detective, they can determine if a planet contains water, organic compounds, or even oxygen. The James Webb Space Telescope is more than an advancement over Hubble. It's a quantum leap. If Hubble's revelations amazed you, prepare for a true celebration of dazzling discoveries as we expand our gaze across the universe's intricate landscape. One star of the show stands out, Proxima b. Since its discovery in 2016, this enigmatic planet has captivated astronomers and anthropologists alike. Why all the excitement? Proxima b resides in our galactic neighborhood, a mere 4.2 light-years away. To put that into perspective, traveling at the speed of light, you'd arrive in just over 4 years, the same time it might take your favorite TV show to cycle back into view. But Proxima b isn't just close, it's also profoundly intriguing. It resides in the habitable zone of its parent star, where conditions are neither too hot nor too cold, potentially allowing liquid water to exist. Picture waterfalls, meandering streams, vast lakes, and perhaps deep oceans as mysterious as the Mariana Trench. Yet, before we start dreaming of visiting, we must consider its peculiarities. A single day on Proxima b is an astonishing 11 Earth days. Imagine sunrises that unfold slowly, resisting afternoon light, and sunsets that linger, creating golden hours that photographers dream of. While idyllic, these extended periods of light and dark have significant implications for its climate and habitability. How would human biorhythms adapt? Would we need to eat more in a day or sleep differently on this strange world? The rhythms of life as we know them would be both tantalizingly familiar and profoundly strange, as though nature is offering us a riddle wrapped in an enigma, challenging our understanding of habitability. How do we gather reliable data about such a world? The James Webb Space Telescope delivers, acting like a giant Swiss Army knife of space exploration. More than a telescope, it's a sophisticated research lab operating in the vacuum of space. Thanks to its innovative technology, cosmologists can observe and examine planets through advanced scientific instruments. Using spectrographs, it analyzes light emitted and reflected by distant worlds, revealing their secrets with precision. Each element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. Space science is not just cosmology, it's space criminal science. We don't sit idly waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky, but a highly specialized research lab, investigator, and vast detective all in one. It allows us to turn our hypotheses and theories about alien worlds into methods to confirm or deny them, changing our understanding of what might exist beyond our blue dot. Just when you thought we had uncovered the most stunning layer of this galactic onion, the story takes an unexpected turn, like a twist in a science fiction thriller. Scientists using the James Webb Space Telescope received something surprising from Proxima b, a signal so astounding that it spread throughout academic halls and social media. Named a potential techno-signature, it was an electromagnetic discharge so complex and intricately designed that it could indicate the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the peak of a discovery that promised to reshape our view of reality. Could this signal be the actual proof that we are not alone in the universe? Just as quickly as it appeared, the signal vanished without repeating, leaving behind a stunning silence, a maze of unanswered questions, and bubbling hypotheses. Was it simply a transitory cosmic anomaly, a random event of infinite arrangement, or something intentional, a coded message or a sign of extraterrestrial intelligence? The Solidar mission cast a shadow of mystery over Proxima b, sparking wild discussions and speculation. Was it merely a passing oddity, or is it part of a much larger, more perplexing story? But wait, the tale of cosmic exploration is far from over. The ink is not yet dry, and new chapters are being written. This time, it's not just conventional specialists, but Harvard researchers leading a shift in perspective. As we continue the search for extraterrestrial life, they are turning the James Webb Space Telescope into a kind of giant night vision instrument to search for artificial light sources in both dark and illuminated areas of distant worlds. Imagine detecting artificial cities glowing like brilliant sparks, a spectacle of advanced civilizations transmitting their presence into the vast cosmos beyond. Proxima b, the quest for life, takes us deeper into space, advances in technology, and a profound desire to understand our place in the universe. This pursuit, with instruments like the James Webb Telescope and ground-based observatories, expands our ability to detect and study exoplanets. A key area of study is the search for biosignatures, signs of life. Atmospheric gases like methane or carbon dioxide, under the right circumstances, could indicate biological processes. The Webb telescope's advanced instruments can measure atmospheric compositions with remarkable precision. By studying starlight filtering through an exoplanet's atmosphere, scientists identify chemical markers characteristic of life, such as water vapor, oxygen, or ozone. Investigating exoplanetary conditions is crucial, as liquid water is considered essential for life as we know it. scientists focus on planets in habitable zones, where temperatures allow stable liquid water. Some moons of exoplanets, like Europa and Enceladus in our solar system, may also harbor subsurface oceans beneath icy crusts. Moons orbiting exoplanets could similarly support life. Additionally, technosignatures, indicators of advanced civilizations, include artificial structures like Dyson spheres or unusual radio transmission patterns. Global collaboration enhances this search. Space agencies, research institutions, and private companies combine resources and expertise. Missions to Mars and beyond, our cooperative efforts pooling talent for shared goals. Public engagement inspires the next generation of scientists. Outreach and education foster interest in STEM fields, encouraging young minds to explore space science. Technological advancements improve our ability to detect distant worlds. Upcoming telescopes, like the Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HABEX, promise even greater insights. Each discovery sparks new questions, pushing the boundaries of our knowledge. The search for extraterrestrial life broadens our understanding of existence and life's diversity, challenging our perceptions and redefining what it means to be alive. In conclusion, exploring exoplanets and seeking extraterrestrial life are dynamic, evolving pursuits. Every step brings us closer to answering humanity's most profound questions. As our exploration continues, the potential for finding life and understanding our cosmic role remains limitless.